Hello everybody, welcome to this webinar. My name is Michael Wiendl. I'm an NC trainer at Heidenhain-Turnreuth, and today I want to show you the programming and possibility of a clamping pyramid on the TNC 640. At first, an overview about the content of the presentation. The first point would be an overview about the possible applications, what we can do together with a clamping pyramid. The second point is the setup of a clamping pyramid, so how to bring in the points in the preset table, in the preset management. The next step, the programming with the 3D basic rotation, which we set up in the preset table, and in the last point, the application examples on the programming station. At first, the possible applications. So why do we use a clamping pyramid on the control here? So you see we have different parts here. So the first thing is that we can clamp more parts on our table instead of using only one clamping device. In the 3-axis milling, it's easy to bring more clamping devices on the table because we only need the access to the workpiece from one direction for the 3-axis programming here. But for the 3+2 axis, for the tilted machining, and also for 5-axis simultaneous machining, we need more range around of the workpiece to, for example, reach the workpiece from 90 degrees from every side of the workpiece. And that's why we want to use a clamping pyramid or a clamping tower on our machine, that that more workpieces run on the machine automatically, and that we just reduce the man time per workpiece during the production process here. And that's why we want to show you how easy it is to work with such a clamping pyramid on the TNC 640. Also, a very important function here is the tool-orientated machining, and this is just a small step inside of the batch process manager, which we can combine here easily when we use more than one workpiece here, for example. The setup of a clamping pyramid, the main point here is the preset management. Because inside of the preset management of the TNC 640 and the TNC 620 and 320 is the 3D basic rotation. And the 3D basic rotation belongs to every preset of the preset management here. So in every preset line, we can see that there is a column SPC, SPB, and SPA. And when we bring in the values to these columns, then we rotate our workpiece around these spatial angles here. I can also combine it with a C offset, for example, to make at first the mechanical adjustment and then in the second step the 3D basic rotation on it. And so we can use the 3D basic rotation for the compensation of the angles from the clamping pyramid here. So a simple example from our programming station here. So we see the preset 20 is active. We see the entry of the preset in the X, Y, and Z, and the C, the B, and the A, the SPC, SPB, and SPA. So we see we have an angle of 29 degrees, and the C270 says that we are on the left side of the table. And now we activate the preset, and then we just program the plane spatial, the SPA 0, SPB 0, SPZ 0. Together with the sim or sequence minus, the control makes the movement. The table goes in the minus direction that we see here in the axis position here. And now the tool is perpendicular to the workpiece surface. So when I use the 3D basic rotation, when I program plane spatial A0, B0, Z0, then the tool is perpendicular to the surface, and I can now do, for example, a 3-axis machining. In the next step, I now program SPA 90 degrees, so a 90 degrees tilted angle on the workpiece. And now the control is calculating and just calculates the 29 of A together with the 90 degrees. And there comes the minus 119 because of the sim minus, the symmetry minus direction says I want to have this angle in the minus direction. And this calculation is always done when I program with spatial angles. And that's the most important information of the 3D basic rotation. When I use a 3D basic rotation and I program a spatial angle on top of the 3D basic rotation, it is always calculated. So always calculated the 3D basic rotation plus the programmed spatial angle from the ANSI program. And that's the big advantage of the 3D basic rotation. And the programmed spatial angle is always calculated in the coordinate system, which is adjusted by the 3D basic rotation. So we always think in this coordinate system of the workpiece. And we do not have to think about any special adjustments from the machine or from the clamping situation. It's just we program our workpiece as it will be without any clamping pyramid here. And that is the big advantage of the 3D basic rotation on our TNC controls here. So let's take a look at the programming. And we just sorted the programming in 4 different applications. So the first is the 3-axis machining. Then we go to the 3+2, so the tilted machining. Then we have the aligned machining or the inclined machining and the simultaneous machining. These 4 applications we now take a look in detail. So the 3-axis machining, there we only need to take care that the tool is perpendicular to the workpiece. So when I activate the preset with my 3D basic rotation in it, I only have to program before every machining the plane spatial A0, B0, Z0. To be sure that the axes are aligned correctly, we can use turn or move, or when we know that the axes are already in the correct position, we can also use stay. And for the reset, we can use here the plane reset possibility. The second often programmed function is the 3+2 axis machining. That we normally program with our plane functions. And the good thing is of the plane function, plane is always spatial angle. So all the plane functions we can use directly together with the 3D basic rotation. And the control calculates the values directly with the 3D basic rotation, and I get the fitting result on the workpiece. So everything works together here. Reset, we can use the normal plane reset, then all the round axes will go. Then all the round axes are calculated automatically together with the 3D basic rotation and the plane functions. The only plane function which is not allowed to use together with the 3D basic rotation is the plane axial function. This is not allowed to use together. And then we come to the CAD-CAM programs. Of course, also the 3-axis and the 3+2 axis can come out of the CAM, but for the in-client machining, there we normally use the CAM system. And there we also have to use the spatial programming, so that we can use, for example, the TCPM axis spatial together with a sentence of L together with round axis A or in C or B and C. So in our example here, it would be a linear sentence with A and C round axis. Or we use the LN, the vector sentence. In the vector sentence, we have the X, Y, and Z coordinate. This is the end point of the sentence. And then we have the NX, NY, and Z part. This is for the radius compensation of the tool. And then we have the TX, TY, and TZ part. And this is for the angle of incidence of the tool regarding to the workpiece. And this LN format is always together with M128 or TCPM. Axis pos or axis spatial is always spatial angle. So these values are always calculated together with the 3D basic rotation, and that we can use for our program. The axis angle, so for example, when we have a linear A and C program together with M128 or TCPM axis position, this is axis angle and is not working together with the 3D basic rotation. So there we have to be careful. The same for the 5-axis simultaneous machining. There we just have our the same functions here, so also the TCPM axis spatial together with the linear sentence with A and C, or the TCPM axis position or M128 together with the vector sentence. And also here, axis angles are not allowed to use together with the 3D basic rotation. So let's take a look at the programming station. So at the programming station, we prepared some examples. So you see here on our clamping pyramid, we have a 3-axis part here. We have a 3+2 axis part here, where we machine it from every side. Then we have a form part here from mold and die possibility. And we have also from mold and die, we have a workpiece with a 5-axis simultaneous process here. So the main information for our clamping pyramid is inside of the preset management. When we activate the preset management, we can see here we have 4 presets for our workpieces, and every preset has a 3D basic rotation. Here we see the SPA angle of 29 and the front side, the right side, the back side, and the left side. So when I activate ANSI program, for example, the part 3 here. Then we see this workpiece belongs to the preset 19, the backside preset, and then we have the blank form already inside. Okay, so let's take a look in the ANSI programs. So how can we program a normal 3-axis program? The normal 3-axis program, we only have to take care that the tool is perpendicular to the surface, so to my workpiece here. And that we can easily do with our plane spatial A0, B0, C0. Now we see the tool is perpendicular. That's the view, program, and workpiece. And when we change to the machine, then we see the view of the workpiece, and the workpiece and the tool is the same. So the control compensates the 3D basic rotation with the A axis and the C axis together and make the situation that the surface is perpendicular to the tool. And then we can go on and everything is programmed here, and we can go on like this. So now we see the 3-axis machining. There it is important that before every machining we program plane spatial A0, Z0, A0, B0, and Z0. This is the important thing in the 3-axis machining. The next step is the part 2. This is now the tilted machining. And when we started, then we see for the untilted machining here on the top, we have the same command like before for the 3-axis, so just a plane spatial with A0, B0, and Z0. And for the next side, we just make a plane reset stay to reset the tilted machining from before. Trans datum axis, this is the format for the new datum shift. Then we go to the save position and we do the plane spatial with SPA plus 70 and SPC minus 90. And that will be calculated from the control together with the 3D basic rotation, and we get the correct machining at this position here. And that is the big advantage of the 3D basic rotation, that the programming stays the same if we have the workpiece clamped without the clamping pyramid or with the clamping pyramid. So this is a very easy thing to just adjust the process or adapt the process with a clamping pyramid when we program with spatial angles here. Then it's an easy way to adapt this process here. So, and when I now press stop, we are now on the 90 degrees tilted. And when I change the view to the status, then we see here it's A minus 61 and C 90. And these are the axis angles, so the at the moment active machine axis angles. And we see it on the transformation. We see the datum shift here, and from the other way, we see here in the label, we see what happens here is the spatial angle what we need for this application here. And this always belongs together. And that's the main reason behind using the 3D basic rotation together with the plane spatial programming here. So let's finish, and then we can go on here. So the next step is then the part 3. So a simple face milling example. So just go on. So it was the normal 3-axis roughing process, and then we program the angle of incidence, and then the machining is completely done together with the 3D basic rotation calculated workpiece system, and so everything we can use as a normal. So for this in-client machining, we can use the spatial angle, for example. In this example here, the angle of incidence comes from a plane command, and everything else is just calculated on this tilted plane coordinate system. It could be also that we use it together with TCPM, with axis spatial, or with M128, together with an LN with a vector sentence. So this vector sentence we see now here, together with our workpiece here, the simultaneous workpiece. And there we see now the ln sentence. So the ln with x, y, and z, this is the endpoint. The nx, ny, and nz coordinate is for the tool compensation, and the tx, ty, and tz part is for the angle of incidence of the tool regarding the workpiece. So these t parts are calculated on the actual tilted working plane. So of course calculated together with the 3D basic rotation, also calculated on an actual plane. So this is a very useful format for ANSI programs. And we can just watch the movement here to see all the calculations are automatically done by the control, together with the 3D basic rotation and the plane possibility here, together with the vector sentence, and this is automatically calculated for the workpiece, together with the 3D basic rotation to compensate the position of the clamping pyramid. And this is a very useful function here to make more parts in one clamping as before. Okay, that was everything from my point here. Thank you for listening and watching this webinar. If you have any questions, do not hesitate to contact me. Just write an email or phone me and ask your questions, or just try it out at your machine. It's a really, you've seen it, an easy function to use. Just take care about the spatial angles, and then you can use the 3D basic rotation very easily. So thank you for listening. Have a nice day. Bye bye.